Revision video here, we're going to be doing standard deviation and the mean with further maths with special guest Benji Eyre. Good to have him on the show. So what we're going to start out doing is a question with a MPQ and MP, and then what we're going to be doing is using the formula to find out standard deviation using a set of numbers. Let's get to it.
Right, today we're going to do some standard deviation, and the question we are doing is: in a certain experiment, probability of success is P. The experiment is carried out 9 times. If mean is equal to standard deviation for 9 trials, find P. So here we've got the root of MPQ equals sigma. This is standard deviation, and the N stands for the number of trials. The P stands for the likelihood of success, and the Q stands for the likelihood of failure. NP equals X bar is the mean. So in this question, N equals 9, because that's the number of trials, and Q is 1 minus P. So we're going to start off by doing square root of 9p brackets 1 minus p equals 9p. So the first thing you want to do is square both sides. So you do 9p brackets 1 minus p equals 81p squared. So now you can see that both of them go into 9, so you can divide both sides by 9. So you can do p brackets 1 minus p equals 9p squared. So now you can expand the brackets, so you do p minus p squared equals 9p squared. And now I'm going to add p squared to both sides, so p equals 10p squared. So now you have to divide p on both sides, so 1 equals 10p, and now you can divide both sides by 10, so 1 divided by 10 equals p. So p equals 0.1, which is the probability of it happening.
Okay, so what we're going to do here is we're going to find the 2 standard deviations for these 5 numbers. The first thing we want to do is find the mean GCSE divided by 5, so you add up all the numbers divided by how many there are. X bar is the mean, and we'll call that 8.8. Now the equation for standard deviation is quite daunting. It's the square root of sigma x minus x bar squared over n, or n minus 1. That'll give us the 2 standard deviations. When we begin to substitute the numbers into the formula, what we're going to be doing is first of all finding sigma x minus x bar squared. These numbers here are called x's. So 5 is one of the x's, minus the mean, 8.8, squared, is one of these 5 things we'll have to do. So we're going to have to do that for all of these different numbers, so it's a bit tedious, but it will give us the answer in the long run. And sometimes they give it to you in the exam, so you have to do all this. 10 minus 8.8 squared. You add them all together because that's what the symbol sigma means. And then we'll find out what that equals. So after you type into your calculator, you should get 26.8 for all these answers, and that is sigma x minus x bar. We're going to divide 26.8 by n, number of trials, or number of things you have. It's going to be 5, or 5 minus 1, which is 4. Now, and then we're going to square root it afterwards, but depending on which standard deviation you're going to find, we're going to use a different one. If you want to find the population standard deviation, I think it is, meaning that what this means is that all these numbers are the entire set of data you have. There's no more data surrounding it. So you won't have a 30 in here you don't know about. This is the whole thing. And so we'll divide by 5 for that one. And that'll be 26.8 divided by 5, square root that number, and that'll be the standard deviation. And if we want to find the sample standard deviation, called SX, meaning that there are more numbers and we've only been given a select sample of the general thing, 26.8 divided by 4, square root that number, and we should get 2.59 as our standard deviation there. Okay.